Hello everyone, today I'm going to be talking about the advent of Code 2020, day 5. And today we are on a plane, and we have to, well, they give us a very cryptic boarding pass that looks like this, FBRLR, like what is this? And based on that, we have to figure out what our seat is. Like, imagine you're Bruce Willis. They give you a boarding pass, you have no idea where you're sitting. He's not going to be a happy guy. But anyway, let's get started. So, first of all, we might want to have a function which can figure what row we are in, such as this. And let's say that the parameter is the boarding pass. So, for example, this would be our boarding pass. So, there are 128 rows on the plane, so let's set some lower limit. The lower limit would be like 0, index 0, which would be like row 1, up to row 28, which would be like index 127. So we are going to do for each character in our boarding pass, and there could be 7 possible. There will always be 7 characters which determine our vertical position on the plane. Let's calculate the midpoint, like so. I'm using integer division here. This will be important in just a second. So, if the character is f, we want to keep the lower half, which would mean that we want to kind of chop off the top half. So we want to decrease the upper limit. And if the character is b, we want to keep the upper half. And we can do lower equals mid. However, if we just do lower equals mid, we're going to run into a problem. So suppose that the first one is a b, then 127 plus 0 divided by 2 would be 63, and lower will be 63. Actually, that will be a problem. Lower should always be even. So we just do lower plus 1. This is kind of just a workaround since we're using a divide by 2 here. So we're good. And after we're done here, after we've finished this entire loop, lower and upper will be the same. So you could return either of them. I will return lower. We can do a similar thing for getting the column. It's basically the same algorithm. We just do 0 and 7 this time. And we're going to use the last 3 numbers, like so. And it's the same thing, mid plus upper divided by 2, but now we're checking if the character is L, not F this time, but L, then we keep the lower half. And if it's R, we keep the upper half. And we are done with this. Now that we have these convenient functions, we can just do like, well, we can do for each boarding pass in our array. We know the row and column though. We get row, get column. And the seat ID, as they tell us, is the row times 8 plus column. This will be unique. If the rows and columns are different, no other person could have the same seat ID. The max seat ID, which is what problem 1 is asking for, I should have written that, get max seat ID, is going to be the maximum of our seat ID and whatever the previous maximum was. And I'll just set the initial equal to 0. Then we return max. That is it. For part 2, we are assuming the plane is full and we have to get the missing seat ID in the sequence. So you can imagine we have an array of seat IDs, like we calculate them all and we end up with something like this. And maybe we have this, and you see there's a gap. 9 would be the seat ID in this case. So we can't assume that the first one is like 0. It's going to be some number, and the last one will be some number, which I think we calculated was 800 something, whatever. but this would be the gap in this case, would be 9. That's the kind of thing we're looking for. So if we store all of the seats into a set for each boarding pass, get the row, get the column, like we did in part 1, calculate the seat, add the seat to our set, then for seat ID in our set, but we're going to start from the minimum of our set and go to the max. And then if there is a gap, like we did not find this one, because we know that the minimum is in our set and the max is in, so if we have a gap, that means that like the next consecutive one was not found. We have found our seat. That is our seat. Else we return none. So that's it for day 5. Thanks for watching.